Hello students, this is the second video for section 4.2 of the textbook, the graph of x equals y squared. And in this video we're going to look at the transformations of y equals the square root of x. Here's the general formula for the transformations. Now you probably have a pretty good idea what a does to the graph, what subtract c does to the graph, and what add d does to the graph. So let's just have a quick look at that using Desmos. Okay, up here is our basically the graph of, the equation y equals square root of x, but with the transformations multiply by a, subtract c from x, and add d. So there's y equals square root of x just there. Now before I move this slider to the right, I want you to basically think to yourself, what's going to happen to the graph when I do this? Okay, let's see what you've thought. So let's look at this point just here. 4, 2 is on this graph. If I make a equal to 2, 4, 2 goes up to 4, 4. And if I make a equal to 3, 4, 2 goes up to 4, 6. In other words, it's multiplying the y-coordinate by a. Okay, let's go back into the fractions. And as you can see, it's basically still multiplying by a, but if you multiply, for example, by 0.5, instead of going further away from the x-axis, it gets closer to the x-axis. So this point here is only half the distance that the original point was. And if you go into the negatives, for example, -1, as usual, it just reflects it across the x-axis. So I'll go out to a equals -3, just so you can see that it's the reflection of a equals +3. And there it is. Okay, any questions on that? Well, I shouldn't say that. You can't ask questions. Let's move on and put that back to, well, that's a silly thing to say. I'll put that back to 1. Now, in your brain, have a think about what's going to happen when I drag the slider c to the right, where c is x, the square root of x takes c. And hopefully, not surprising, if I make c equal to 2, okay, the point that was at 0 has just moved across 2 units, 2 to the right. The point that was at 6, 2, 6 has moved across to 8. So what c does, as you hopefully expected, is it just basically does a horizontal translation. If c is positive, it's to the right, and if c is negative, it's to the left. So in this case, the graph has moved back to -2. And of course, d does what it does in all the other functions. If you add, for example, 2 onto this, it's just going to increase the y-coordinate by 2, and that's going to have the effect of doing a vertical translation. So the point that was at 6, 2, well, first off, the point that was at the origin has now been lifted up to 2, y equals 2. The point that was at 6, 2 has been moved up to 6, 4. So that just does a vertical translation. And that's pretty much all there is to transformations of exponential functions, of inverse functions. Okay, let's go ahead and actually try some questions based on that. Okay, once again, we're only going to do question C. If you can do this one, you can do the others, although after we've done this one, I suggest you try some of the others. So given that function just there, we're going to sketch the graph of that, showing the coordinates of the vertex and any axis intercepts. And if we need to, we'll put an additional point on the graph so we can actually draw the graph a bit more accurately. So, what are the transformations that we've done to y equals square root of x? Well, we've multiplied by 2, and as you hopefully remember, that's going to basically be a vertical dilation parallel to the y-axis, away from the x-axis, by a factor of 2. And the +3 on the end is going to lift the whole graph by 3. So there's my beautiful graph just there. And I chose the point x equals 4 because the square root of 4 is 2. 2 times 2 is 4, plus 3 is 7. So that gives me a point on the graph. Okay, and identify the domain and range using interval notation. Well, the domain basically goes from 0 out to positive infinity. So that's how we write that using interval notation. Notice that 0 is included, so we have a square bracket. Infinity, you always use a curved bracket because you can't actually go out to infinity. And the range is the set of possible y values, where the smallest one is 3, and that goes up to positive infinity as well. So that's the answer to question 13C. Okay, try at least one other one just to get a bit of practice at this. And moving on to this one, excuse me, a little bit harder. For each of the following functions, sketch the graph showing the vertex and any axis intercepts, and identify the domain and range. Okay, so in this case, we've got a -1 outside the square root of x. And of course, what the negative does out there is it flips the graph in the x-axis, and this moves the graph down by 1. So there's my beautiful graph just there. Once again, I chose a point so I can actually draw the graph a bit more accurately. So I said when x equals 4, square root of 4 is 2, -2 minus 1 is -3. And the domain and range, well, the domain, x goes from 0 out to positive infinity. I wrote it this time using my preferred way of writing it, just using the less than and greater than signs. And the range, basically the biggest y I can get is -1, and it just gets smaller and smaller and smaller. So y goes from negative infinity up to 1, and that means including 1. And that's the answer to 14C. So you might want to try, for example, 14D on your own and check the answer. Okay, last one. This one's a little bit more challenging. Sketch the following functions using technology. Oh, that makes it easy. I didn't read that. And identify the coordinates of the vertex and the axis intercepts. Let's do it using algebra, since that's the way that I did it. So this actually is quite easy now because you can just go ahead and graph it. And there's functions on your calculator to find all the answers to all of those questions. Okay, let's have a look at question D. Okay, so there's the graph just there. So what have I done just there? Okay, decided to rewrite for take x is -x plus 4. And then I decided to rewrite it as negative brackets x take 4. So why did I do that? Well, the reason is, if we've got a negative sign there, this acts like the b in things like trig functions. If you have a negative sign in there, that basically flips the graph across the y-axis, and this one flips the graph across the x-axis. And this, of course, moves the whole graph 4 units to the right, and this one moves the whole graph 4 units up. So you might want to see if you can actually sketch a graph of that on your own, and then check it against my answer. So, well, first, here's the things that I just talked about. Okay, it's reflected across the y-axis, x-axis, reflected across the y-axis. Horizontal translation of 4 units to the right. Vertical translation of 4 units up, so therefore the vertex is at 4, 4. Okay, to find the y-intercept without using a calculator, we set x equal to 0. Oops. And that just means you got 4 minus 0, which is 4. Square root of 4 is 2. So we've got -2 plus 4, which is +2. So the y-intercept is at 0, 2. The x-intercept, we set y equal to 0. Again, you might want to try this one. This one takes a little bit of algebra. So put 0 in for y, and now we've got to solve this equation for x. So I moved this to the other side to make it positive, because I don't like negative numbers. The second step is I squared both sides to get rid of the square root. And finally, 4 take x is 16. Well, 4 take negative 12 is 16. Because subtracting a negative is the same as adding a positive. And therefore, the x-intercept is negative 12, 0. And finally, I just took the graph from the answers. So there's what the graph of the function looks like with the domain and range. So it's not the whole graph, it's just the part that we need for that. Okie doke, so let's leave it at that, and that's the end of our section on transformations of x equals y squared.